Hi everyone. Today's topic will be graphing by table of values. If you're able to print this lesson to work through it, that'll make everything a little bit easier since we're going to be working through on a grid. If not, no worries, just follow along with the process. As soon as you're able to work through on your own, as soon as you feel comfortable to attempt some of these problems on your own, I want you to pause the video, work ahead a little bit, and then see if we match up. Try to make it as much as you can like being in class. Okay, let's begin. I want everybody to take a look at the instruction, which is complete the table of values and then graph the relation. So what you'll notice is you've been given the equation to a relation, y equals x plus 2, and now you've been asked to complete the table of values. Notice that you have two columns. The first column, drawing to your attention, that it represents the x value. And so notice that we've given you three x values, -4, 1, and 3. And so what we're missing then is the y value. So your job is to come up with the y value that matches each of those x values. So let's start off with the first one. We need to find the matching y value for an x value of -4. And so what we need to do then is to sub x equals -4 back into our equation. And so I've got y equals -4 plus 2. And now I can simply calculate and come up with a value of -2. That tells me that the y value of -2 is what matches up with an x value of -4. Now, all that blue writing that you see, we don't need to see any of that. If we ever gave you the instruction to complete a table of values, if you feel comfortable evaluating all of that in your head, feel free. So to take a look at the next one then, I need to come up with the y value for when x equals 1. So I can sub in for x a value of 1, and so I get 1 plus 2, 3. Notice, just show me the green and you're good. As soon as you feel comfortable doing those operations in your head, feel free. And so on the last one, I now need to find the y value that matches up with an x value of 3. So if I replace my x with a value of 3, I've got 3 plus 2, and there's my 5. There is us completing a table of values. All I would ever need to see is the table itself. None of the work to get down to those y values needs to be shown. Feel free to do it, but it never needs to be shown. Now we can jump ahead and we can go over onto our graph because we're now going to graph this relation. And so I now have a series of coordinates of ordered pairs. When you take a look at that first row in our ordered pairs, as I just get rid of all that x, what you ended up doing when you worked your way through and you came up with that y value of -2 is you then found your matching x coordinate. And so therefore, y coordinate. So when I have an x value of -4, that tells me I have a y value of -2, which allows me to plot a point at -4, -2. Don't label your point, it's never needed. But we can now continue on and we can now plot every successive point. An x value of 1 gave me a y value of 3, and an x value of 3 gave me a y value of 5. And so if I plot the two remaining points, I would then have a point at 1, 3, and 3, 5. I now have 3 points. The only thing left for me to do is to connect those 3 points. I can see the shape that they would represent. It would be a line. And so taking a straight edge and connecting those 3 points is good. Always extend your line the size of the grid so it takes up all the space provided. And then, since we know that graph will go on forever in both directions, I put arrows on the end. Now, you may be saying, how do you know it goes on forever and ever in both directions? I want you to notice that what we've come up with are 3 points on that graph, but we haven't come up with all the points on that graph. I could now go through and choose a separate x value. And maybe I chose an x value of 10. Well, I could come up with the matching y value for that. As I replace my x with 10, I have 10 plus 2, there is 12. There would be another point on that line at 10, 12. Notice it does not fit on my grid. But I would be somewhere way over onto the right and way up at the top, somewhere up here maybe. And notice that my line would go through it. So we always put arrows on the ends of our graphs when we know that that graph goes off in that direction. Now what we want to do is slide down and take a look at our relation in B. In B, we gave you a little bit of an uglier relation, y equals x squared, but we can go through that exact same process. And so, to start off, for me to come up with my y equals x squared, when x equals negative 2, I would sub in an x value of negative 2 wherever I see the x. Notice I put brackets around that negative 2 because I need to make sure that I square the entire negative 2. So negative 2 squared is negative 2 times negative 2, and there is my 4. And so I have my y value of 4. As we go through that same process, we may feel comfortable to now finish off that table. I'd like everybody to pause the video right now and give it a shot. Okay, welcome back. We should be able to go through and do the rest of that table in our head. I can replace my x with a negative 1, so negative 1 squared is 1. I can replace my x with 0, 0 squared is 0. I can replace my x with 1, 1 squared is 1. And I can replace my x with 2, 2 squared is 4. Notice I now have 5 points that I would be able to go through and graph. So I don't need to write out the ordered pairs, I can see the ordered pairs. So if I take a look at the first one, when x equals negative 2, y equals 4. So I can plot a point at negative 2, 4. And now I can go through the same for all those remaining points. I have a point at negative 1, 1. I have a point at 0, 0. I have a point at 1, 1. And I have a point at 2, 4. Now the first thing I want you to notice, that's clearly not a line. Those points would not fall into a line. However, it does seem that there's a sort of a pattern to it. So if I was to now try to connect all of those points with a pattern, I notice that I'm going to curve around on these 3 points. And then for me to connect this one to this one means that I would curve up. And for me to connect the last ones mean I would curve up. Now, is it possible that I could sub in an x value of 3? Sure, because 3 squared is 9. And so I would have a point way up here at 3, 9. And so I feel very confident to be able to extend that graph and put an arrow on the end. Notice we could do the same thing going backwards. I could replace that x with a negative 3, and therefore negative 3 squared is 9. I would have another point way up here somewhere, and so I could connect and extend and put on my arrow. And there we go. So if I go through the graph using a table of values, I can plot my points, connect my curve in the pattern I see, and make sure that it takes up the full grid for that shape. Okay, I want to take a look now down at C. We're going to repeat this pattern, but the rest of the problems for us now are going to be identifying a couple key features. First off, take a look at C. Yes, you notice you have a big ugly fraction in that equation. If I take a look at that equation, notice all the x values that I chose to put in my table. Why did I choose all of those x values? Because now, if I went through to sub in an x value of negative 6, I get my y value of 2/3 times negative 6 plus 1. You may notice why I really like the fact that I have a 6 as my x value. Because when I go through to calculate negative 2 times 6, I notice that I can cross-reduce in my fraction. Now, if you don't like that cross-reduction, then go ahead and just calculate 2/3 times negative 6. So we have the 2 times, and then divided by. In either case, as we work our way through, I should notice that that will reduce to a negative 4. Through cross-reducing, I have 2 times negative 2, or through simply calculating, I have 2 times negative 6, which is negative 12, divide that by 3, negative 4. By me choosing a value of 6 or negative 6 in that table for my x, it allowed me to avoid working with fractions in the future. I now have a y value of negative 3 that matches up. So notice, every single one of my x values are all values that would divide by 3 evenly. So very quickly, I should be able to work my way through. If I replace my x with a negative 3, then I can cross-reduce. There's my negative 1. I have 2 times negative 1. Add on 1. And there's my negative 1. The rest of these I should be good to be able to work through in my head. 2/3 times 0 gives me 0. Add on your 1. 2/3 times 3 is 2. Add on 1. And 2/3 times 6 is 4. Add on 1, 5. Now I can plot all my points. Negative 6, 1, 2, 3, 4, 5, 6. Oh, shoot. Negative 6 is off the graph. That means I do not graph it. I will just use that point to help me with the pattern. I can graph negative 1, 2, 3, and 1, negative 1. I can graph 0, 1. I can graph 3, 3. But I notice the same thing with 6, 5. That's going to put me off my graph. And so I use it to help me with my pattern. Those 3 lines seem to form in the shape of a, those 3 points seem to form the shape of a line. Connect them, extend it the full width of the grid, arrows on the end, and we have our line. Okay, moving forward, I think we should be a lot more comfortable then to be able to work through even some ugly stuff. Okay, let's take a look at this first practice problem for us to be able to work through. Notice the big adjustment on question A. I have not given you any x values. And if I don't give you any x values, then that means you need to choose the x values. So there's nothing in that equation that makes me think that there's any more important x values to choose than others. And so what I'm going to do is I'm going to pick a few x values. I'm going to pick the easiest number to sub in, which is always 0. I'm going to pick a nice, easy, positive number. And maybe I pick a nice, easy, negative number. Now, maybe 3 points will not be enough for me to be able to figure out my graph, so maybe I extend that a little bit, and I pick the next easiest positive and the next easiest negative. Now I need to take those x values, and I need to sub them in to figure out what the matching y coordinate is. So, if I sub in my 0, that's nice and easy to calculate. If I sub in my 1, if I sub in my negative 1, if I sub in my 2, and if I sub in my negative 2. Now I have 5 points. I can feel comfortable to go through and graph. And so, if I go through and plot all of those points, I'll have a point at 0, 1. I'll have a point at 1, negative 1. At negative 1, 3. I'm already starting to anticipate my graph. And so my next point at 2, -3 gives me a little confirmation of the shape I see. And my last point at -2, 5 makes me feel really confident. Those 5 points all line up. And so I'm going to connect those 5 points, extend it the width of the grid, arrows on the end. If I was to slide down now, I think we should all feel a lot more comfortable moving forward. So you guys go ahead, choose your X values, find the matching Y values, and we'll see if we match up. Pause the video now and jump ahead. Okay, welcome back. I'm hoping that when you guys took a look at the equation given in B, you noticed that we had a divide by 5. And so that means that when I'm choosing my X values, I didn't just blindly pick a couple negatives, pick a couple positives. I wanted to pick X values that made my life easier. Well, regardless of the divide by 5, a 0 is a nice, easy number to sub in. Because when I choose 0 and I sub it in, 2/5 times 0 is 0. I can come up with that value of -3 very quickly. However, I'm not going to choose an X value of 1, because if I choose an X value of 1, now I have 2/5 minus 3. I'm stuck finding a common denominator and simplifying when I could have avoided that issue. If you recall from earlier, we had a fraction in one of our equations. And the best thing to do was to pick multiples of that denominator. If I have a divide by 5 in my equation, then I want to pick all numbers that have a 5 as a factor. So the easiest, pick 5. The next multiple of 5 would be 10. However, some people may have found it just as easy to work with -5. And lastly, we can come up with -10. For us to work through then, I'm going to write down one last time us making that substitution. And so I'm going to replace my X with a value of 5. And now I need to calculate. The nice thing is my 5's divide out, which is good. That's the whole reason why I picked it. Which means that I am left with a 2 minus 3, no fractions to work with. And I can simplify that down as fast as possible. So moving forward then, I can replace my X with 10. 2 times 10 is 20. 20 divided by 5 is 4. 4 minus 3, 1. I can replace my X with -5. Well, 2 times -5 is -10. Divided by 5 is -1. Subtract 3. Replace my X with -10. 2 times -10 is -20. -20 divided by 5 is -4. -4 minus 3, -7. We now have all our points that are needed. Time to plot and connect. So I can plot my point at 0, -3, at 1, 2, 3, 4, 5, and -1. Plot my point at 10 and 1. I can already start to see my shape coming along. Therefore, -5, -4 is starting to confirm that. And -10, -7 throws me out of whack a little bit. So I'm starting to take a look at that and I'm saying, okay, wait a second. That seems a little weird. I've got these 4 lines that seem to be lining up. Okay, these 3 lines really, these 3 points really seem to line up. But then all of a sudden, my next points don't seem to. Okay, I got to go back and I got to see, is this a weird pattern or did I make a calculation error? So if I work my way back, I'm now going to sub my X value of -5. And so when I sub in that X value of -5, I'm now going to have y equals 2/5 times -5 minus 3. And now I can calculate. My 2 times -5 is -10. -10 divided by 5 is -2. And so -2 gives me a -5. And so this was a mistake up here when I found a y value of -5 or 4. It really should have been -5. And so therefore, as I take a look, this point was actually incorrect. That as I went through, I shouldn't have had a point there. I should have had a point at -1, 2, 3, 4, 5, -1, 2, 3, 4, 5, at that location. And notice that that does then fit into the pattern of all of our points. And so now when I connect all 5 of those points, I'm going to now get that relation as its picture. So we're going to go through and we're going to make mistakes from time to time as we fill in our table. You have the means to go back and find those mistakes. I want to now scroll down to question C, because question C gives you what could look like kind of a weird equation. It's different than one of the ones that we've seen, but I want you guys to notice it's actually pretty direct. As you work your way through and you take a peek at that, I have to now pick some x values to sub into my equation. I'm going to pick the easiest one to sub in, and I'm maybe going to pick a couple positives and a couple negatives. As I make the substitution of x equals 0, you may ask yourself, but there is no x. And so when x equals 0, you'll notice, since there is nowhere to sub in x equals 0, my equation remains the same. So when x equals 0, y is 2. And if you scan your way down the rest of the points, you're actually going to see, well, then when x is 1, y is 2. When x is 2, y is 2. More importantly, take a look at what that equation says. It says that your y value is 2. That means your y value is always 2. And so, if I was now to plot all the points where my y value is -2, you will notice that we get a horizontal line where y is equal to 2. So even though the equation may have looked a little different, it was actually a lot easier to graph. Our last problem then is going to be one for us to be able to work our way through. So what we end up having then is this big, ugly equation in D. I want everybody to pause the video, give it a shot, and we'll see if we match up. Okay, we're back. The biggest issue, I think, when you guys go through to be able to construct your table is, yes, we pick the easiest value, and we pick a couple positives and maybe a couple negatives, because there are no fractions in that equation. We work our way through. Notice, for me to sub in an x value of 0 means that I have 2 places to make that substitution, because I have 2 x's. That means I have to sub in my x value everywhere. And so the nice part about subbing in 0 is that's going to wipe out the first term, because 0 squared is 0. 0 times -2 is 0. It's going to wipe out the second term, because 4 times 0 is 0. And I'm going to be left with -2. So 0 gives me -2. And some people are going to feel really comfortable to start to plot their points as they construct their table. We make a substitution of 1, and maybe you start to feel more confident to do it in your head. I need to sub in and calculate my squared. So 1 squared is 1. So I have -2 times 1 is -2. You make your substitution in for the other x value. 4 times 1 is 4. And now you just have a little calculation to make. -2 plus 4 minus 2 is 0. So I have a point at 1, 0. We can do the same thing to match up with our 2. 2 squared is 4. 4 times negative 2 is negative 8. 4 times 2 is 8. And now we calculate, and we find our matching value. Therefore, I have a point at 2, negative 2. Now, I'm going to go through, and I'm going to show the substitution on the next one, specifically us subbing in an x value of negative 1, because there is a very common mistake. So, replace your x with negative 1, and now we calculate. And so, as we're working our way through to calculate that, you guys will notice that negative 1 squared is a positive 1. Positive 1 times negative 2, my first term simplifies to negative 2. Now I can calculate. Negative 2 minus 4 minus 2 is negative 8. And I have my value. Do the same substitution for an x value of negative 2. Maybe we get a little bit faster. Negative 2 squared is 4. And now you work your way through. You have a negative 2 times 4. You have a 4 times negative 2. And we calculate that one, and that is going to get us way down there at negative 18. So if I plot my last 2 points, I have a point at negative 1, negative 8. I can't plot the point at negative 2, negative 18 because it's way off the grid, but it gives me an idea of the curve. So maybe I can see this pattern developing. But then that means that I need to extend my table a little bit. So now what I may need to do is I need to see what's going off on the right side. So if I went through and said, well, what about at an x value of 3? I want everybody to sub in an x value of 3 and calculate your y value. Okay, we're back. 3 squared is going to equal 9. Just to give us a little bit of room to work with. 3 squared is going to give us 9, so I have negative 2 times 9. I have to sub in my 3, and the rest is calculating. So negative 18 plus 12 is negative 6. Negative 6 minus 2 is negative 8. And so I would have my matching y value. If I was to then go through and plot that point, I can now plot my point at 3, negative 8, and I feel a lot more confident in what that curve should look like. And so if I extend my graph down, and there we go. So we started very basic, worked up to pretty ugly in the last one. Your job now is just to work through some practice and try to make graphing and constructing table of values and relations pretty automatic. Okay, good luck everybody.